Try again, year 9. Right, okay, this time we are looking at the relationship between the 3 different ideas that we've been talking about over this last week. So we're looking at the relationship between current. Remember, current is represented by an I. I know it doesn't make any sense, but that's how it is. There's a relationship between current, resistance and potential difference. Now remember, potential difference is also the same as voltage, okay? So we're going to look at the relationship between the 3 of them. So like we said before, resistance is a measure of how hard it is for electrons to move in an electric circuit. So resistance is trying to prevent that electric current from flowing. Now George Ohm, it's named after the unit, he was the one that found this connection between these 3 different factors. Okay, so he came up with a formula of V equals I multiplied by R, and that's now known as Ohm's law. Okay, so we've got another few calculations to do, but you just follow it in exactly the same way as you did for the charge on Friday. Okay, but like we said, the little symbol for ohm is named after George Ohm, and it's that funny little Greek letter there. Okay then, so again, doing calculations, you just need to think about putting it into a formula triangle and using it in exactly the same way. Okay, so we've got our voltage, which is written as V, our current is I, that is one that you do need to remember, and then resistance, which is R. Okay, so if you remember V equals IR, then you can try and rearrange it. Okay, so we'll put it into the triangle. I'll just skip through that. So again, we use this in exactly the same way as we did for the charge. Depending on what it is that you want to find out, you cover that up with your finger. Okay, so if I wanted to know voltage, then I'm going to cover that up with my finger, and that gives me the calculation of I for current multiplied by R for resistance. Okay, if I want to know I, then I cover that up with my finger, and that will give me the calculation of voltage divided by resistance. So it works in exactly the same way as the ones that you've used for charge. Okay, you just need to use the triangle. Okay, so in that case, I equals V divided by R. So just as an example, whenever you've got a question that has a sentence in it, the best thing that you can do is to circle the values that you've been given. So we know there that we've got a bulb with a current of 0.2 amps and a potential difference or a voltage of 5 volts. So we know I and we know V, and we want to know the resistance. So we need to rearrange the equation. We've got V equals IR, so rearranging that, resistance will give me V divided by I. So I just substitute in my numbers. I've got 5 from the top, of the question at the top. So I've got 5 volts divided by 0.2 amps, and that will give me a resistance of 25 ohms. Okay, so you've then now got on here a number of slides and tables for you to practice doing those calculations. Okay, the answers are at the end. I've also put 2 sheets onto class charts for you to complete. One of them is quite straightforward, one of them is super tricky, and I'm going to go through the first question of that sheet with you. Okay, so if you want to have a go at this one, I know it looks particularly daunting and scary because it's all diagrams and numbers, okay, but you can actually think of it like a logic puzzle and you can work it out. Okay, so in this case, for the first one, it's asking you about current, it's asking you about voltage. It doesn't include resistance on this one, so this one's quite straightforward. So we've got a parallel circuit. Now I know straight away that my voltage across the battery or across the power pack is 3 volts. Okay, now because I know about parallel circuits, I know that each branch will take exactly the same voltage as the battery. So in that case, this branch here, this bulb, is using 3 volts. When I come down here, this branch is also using 3 volts, but because there are 2 bulbs in that branch, it has to share that voltage. It shares that energy. So I've got 3 going through the branch, but that's divided by 2 bulbs. So each bulb will have a voltage of 1.5. Okay, so that's how you work out the voltage. With the current, okay, I know that the current in this branch is 0.2 because it's a parallel circuit, I know that the current is split between the branches, okay? So if the current in this branch is 0.2, then the current in this branch is also going to be 0.2 because it's split here. When it got to this junction here, half of it went this way and half of it went that way. So in that case, A1 must have a current of 0.2 amps. Now, to work out the last ammeter, when the branches come back together and get to this junction here, they will actually add back together. Okay, so I've got 0.2 amps coming from this branch, I've got 0.2 amps coming from this branch, so that will give me a total of 0.4 amps. Okay, so if you work through it logically, right, and have it as a little bit of a puzzle, it is quite challenging, this sheet, but I'm sure you can have a go, and I will post the answers tomorrow.